Welcome to week 6 in geometry. Um, at this time, I want you to make sure you've got your math notebook out. A lot of today is going to be review in this recording as well as an intro into Unit 2. We're wrapping up Unit 1 this week, taking the test. So I'm going to do a lot of review in the beginning of this recording and then second half jump into some Unit 2 material. So it's going to be super beneficial to make sure you've got your math notebook out and use that pause button so that you can click on pause and try some problems and work through them on your own in your math notebook, and then you can click play and check your work with mine. So I do want you to be interactive with this recording, and you can be. So let's go ahead and get started. I know you've all got your math notebook out. If you don't, go ahead and click pause and grab it. And I want you to find the distance between points 5, -2, and 0.13. So this is a great warm-up question on the distance formula. You will see a problem like this on the test. So go ahead and click pause, try it on your own, and then when you're ready to check your work with mine, go ahead and click play. All right, so we need to first write down the distance formula so that we can solve this problem. So to find the distance between any 2 points, you are going to subtract your x-coordinates. I always like to subtract my second x-coordinate, subtract it by my first x-coordinate, and then I square that answer, and I add it to the difference between my y-coordinates, and then I square that difference. So let's go ahead, and this would be my first point, so I call this x1 and y1. This is my second point, so I call it my second x-coordinate and my second y-coordinate. So plugging into this formula, I'm going to subtract my x-coordinates. I'm going to take 1 minus 5, and I'll square that. I'll do that in just a moment here. Let's continue setting this up. Subtract my y-coordinates, 3 minus -2. Note that there's a double negative there. I'm subtracting a negative number, so there's a double negative. All right, so now let's go through and clean this up. So when I subtract 1 minus 5, I get -4. I'll square that in my next step. Whenever I have two negatives right next to each other, it becomes a positive. So I'm really adding 3 plus 2 to get 5. And then I'm going to square that. Now we're ready to do the squaring. -4 squared is the same as -4 times -4, which I know is 16. 5 squared is 25. So what do I get when I add 16 plus 25? You get 41. And is 41 a perfect square? No. Are there any perfect square factors? Can I multiply? I'm looking for multiples of 41 that have a perfect square. No. So square root of 41 is going to be my most exact answer. If I were to type it in my calculator and get a decimal, I'd probably get a pretty long decimal. Let's try it. Square root of 41 is 6.403124, blah, 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 keeps going. So I would have had, if I put it in a decimal form, I would have to round. So I'm just going to leave my answer as square root of 41 because that's my most exact answer. I don't have to do any rounding. So sometimes it's better to just leave your answer as a square root of a number so that you have your most exact answer. You don't have to do any rounding. All right, going on to the next slide. So if you need more time, go ahead and click pause. So this week, we are going to finish up Unit 1. We're going to take the Unit 1 test. And this is the last week to submit redos for Unit 1 because we're taking the Unit 1 test. So please note that. Submitting redos is a fantastic way to study for the Unit 1 test. Remember, all of them are due on Monday, so make sure that If you want to redo anything from Unit 1, now is your chance. Once we move on to next week, I will not accept any more redos from Unit 1. So this is your last week to submit redos for Unit 1. And then we're going to start a brand new unit. And it's going to be all about triangles. Alrighty, so here we go with some Unit 1 review. So this is a great opportunity for you guys to click pause and try these problems on your own to see what you need to review, how much you already know. It's just a great review. So take advantage of clicking the pause and trying some work on your own, and then you can click play and check your work with mine. So we're going to start with a problem. See it below. We've got two parallel lines intersected by a transversal. And in Unit 1, we learned about all the different angle pairs that we can create when we have two parallel lines intersected by a transversal. So using this diagram, I want you to find the measurement of angle GHK. So we're only given one angle measurement here. And can you use the patterns and angle pairs that we learned about to find the measurement of GHK? So go ahead and click pause and try this on your own. And when you're ready to check your work with mine, go ahead and click play. All right, so our first step is let's go ahead and find where that angle is that we need to find the measurement of, GHK. So GHK, here we go, right there. So we need to find this angle measurement using the measure of DGH that's given to us. So what kind of angle pairs are these two angles? What do we have here? Well, they're on the inside of our parallel lines, so we know they're interior angles, and they're alternating the transversal, so we call them alternate interior angles. And what do we know about alternate interior angles? We know that they are congruent. They are congruent. So we know then that if the measurement of angle DGH is 131, then the measurement of angle GHK must also be 131 degrees. So there's your answer right there. And we were able to solve this because we first identified the angle pairs. It was a set of alternate interior angles, which we know are congruent. Therefore, we were able to identify the measurement of angle GHK as 131 degrees. So moving on to the next slide. Another review question. Here we've got another set of parallel lines intersected by a transversal, and we've got two of our angles labeled, and you need to find the value of y. Go ahead and click pause, try this on your own, and when you're ready to check your work with mine, go ahead and click play. So first of all, what kind of angles are these two angles? What kind of angle pair is this? They are same side interior angles. They are same side interior angles. What do we know about same side interior angles? They are supplementary. They are not congruent, but instead they are supplementary, meaning that if we add these two angle measurements together, they have to add up to 180 degrees. So we are going to plug in our two angles, the measurements we are given for each angle, 64 and 4y plus 16, set it equal to 180 degrees. Now we've got a nice algebraic equation where we can solve for y. I'm going to combine my like terms on the left side of my equation. I see that I have a 64 and a 16. Those are both constant terms. So I can add those together, and when I do, I get 80. 64 plus 16 is 80 plus 4y equals 180. Then I'm going to subtract 80 from both sides, work on getting y all alone. Left with 4y on the left side and 100 on the right side. 180 minus 80 is 100. Divide each side by 4, and I get y equals 25. That's my final answer. I was only asked to solve for y, so I can stop there. Remember to always read through and answer all the parts of the questions. I might have asked you to find this angle measurement here, but I didn't. I only asked you to solve for y. Just again, make sure when you're done that you are really done, that you've answered all parts of the question. So that's going to be our last problem of the Unit 1 review. I do want to get into and introduce some material from Unit 2. So obviously we covered just a very small portion of review from Unit 1. So make sure you are reviewing all of Unit 1 before you take the Unit 1 test. Again, redoing low scoring assignments is a fantastic way to study for your test. And all redos are due this coming Monday. So keep that in mind. So Unit 2, all about triangles. Triangles, three-sided figures, right? Lots of theorems are going to be presented to you in Unit 2, so make sure that you are writing down the theorems in your math notebook. I recommend maybe a theorem section in your math notebook. And just again, make sure you're taking good notes as you go through Unit 2. All right, so as you start Unit 2, there are some very important notations that you're going to see on the sides of triangles or in the angles of triangles, and it's very important that we understand what these notations mean. So here's some different notations on the sides of some triangles. So look at here how we've got one little tick on this leg and one little tick on this leg of that triangle. Well, that means that those sides have the same length. They are congruent. So because there's one tick here and one tick here, it's telling us that the length of AB is equal to the length of AC. There is not a tick on BC, so that side length would not have the same measurement as the other two legs of that triangle. So on the next triangle, we see that there's one tick here, two ticks on this side, and three on this. So since there's not the same number of ticks on any of our legs, it lets us know that all those legs have different side lengths. So here on this triangle, there's three ticks. Each of them are only one tick. So that lets us know that all three legs would be congruent. So ticks are very important because they tell us the side lengths, which side lengths are congruent. Now, let's also talk about different types of triangles. I actually have three different types of triangles on this slide. One is equilateral, one is isosceles, and one is scalene. So I'm going to get rid of the notations that I have. So let's look at this first triangle. We know there's one tick here and one tick here. We know we've got two legs that are the same and our third leg is not the same. So this is what we call an isosceles triangle. We call it an isosceles triangle. You've got two legs that are congruent. In our next triangle, we've got all different number of ticks on all three legs so that we know that all three legs have different lengths. And we call this type of triangle does anybody know? Scalene. When you've got three different side lengths, it's scalene. Our last triangle, we have one tick on each side. So we know all three sides are congruent, which means this is an equilateral triangle. I'm going to move on to the next slide. Now that we know how to name our triangles based on the side lengths, let's move on. So there's different notations. Not only can we use notations for side lengths, but we can also use notations for angle measurements. So let's look at these two sides here. I see that side VW and YZ each have one tick. So that tells us that the side VW is equal to side YZ. Now let's focus on these arcs for the angle measurements. So same thing is true With the side lengths having 1 tick and then 2 ticks and 3 ticks, same thing is true for angle measurements. So look at how this angle right here only has 1 arc and this one has 1 arc over here. That lets us know that these two angles are congruent. So we could say that the measurement of angle U is equal to the measurement of angle X. And then looking at, let's do a different color again. Angle V has 2 arcs and angle Y has 2 arcs. So we know then that these two angles are congruent. We could say that the measurement of angle V is equal to the measurement of angle Y. So these ticks and these arcs and the number that there are very important indicators for us. They let us know which sides are equal and they let us know which angle measurements are equal. So make sure that you are paying attention to the notations, as that's going to be very helpful for solving problems in Unit 2. I'm ready to move on now. All right. So did you know that if you add up all the angles in all your in a triangle, so if you add up all 3 angles in every triangle, you're always going to get the same sum? So there's always going to be a total of 180 degrees in every triangle. So if we add the 3 angles together, every triangle, we're always going to get 180 degrees. Our triangles might look different, but the sum of all of our angles is always going to be 180 degrees. We can use this to help us solve for missing angles of triangles, just like this triangle that we have below. So we've got one missing angle measurement right here. We'll call this X. So are we able to now, with the knowledge that we just learned that there's a total of 180 degrees in every triangle, can we find this missing angle right here? Sure we can, because we know if we add all of our angle measurements, which is X, 49, and 47, if we add all those together, we should get 180 degrees. So now we've got a nice algebraic equation that we can solve for X. We can add together 49 plus 47 and get a total of 96. And then if we subtract each side by 96, we're going to get that value of that missing angle measurement. 180 degrees minus 96 is 84. So that missing angle measurement right here is going to be 84 degrees. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. And that's it for today. So I just wanted to give you some basics of what you're going to see in Unit 2, and then those notations are so important. Let me put up your key phrase question. So you got 2 questions you got to answer this week for your key phrase assignment. The first one is, when is the last day to submit Unit 1 redos? This is important. And then, what do you know about the sides BC and EF of those triangles below? And that's it. So there's some special notation that we learned about that will help you answer question 2. Have a great rest of your week, and if you need help with anything, let me know.